Hey guys, I hope you're all doing really well this week. This is a Lenovo B50-30. Now, you might remember this model number because that is the same model number as this one right here, which we fixed last week. But I've got a second one that's exactly the same model as part of that same batch of 14 laptops that I bought secondhand. So it's the same drill with this one. I've no screen, I've no keyboard, I just have the basic chassis and a motherboard. This comes with a motherboard that is reported to be faulty. So what I'm going to do is I'm going to pull out the motherboard, I'm going to plug it in, and we're going to see what's happening with it. I've taken out the motherboard, I've plugged it in to our Lenovo adapter, and I've plugged it into HDMI for display. And as you can see, we do have an LED light here. So that means that, well, first of all, our main power rail must be working, and secondly, our 3.3 volt must be working. So I'm assuming we also have 3.3 on the power button. So I'm going to press the power button and see what happens. Okay, and we've got a light on that also. So the next thing is, do we have display? Well, we've nothing on the display so far. I can't feel the processor heating up. So we do have 3.3 volt. The power button does seem to be working, but it's just not coming on. Let me press and hold it and see is it responding when I switch it off. Okay, so it is responding to that as well. Okay, so I'll tell you what I'm going to do. I'm going to take the pictures as usual. I'm going to take it onto the screen and we're going to do a visual inspection. I've scanned the board in front and back, so as you see it came out quite well. So what I'm going to do is a quick visual inspection. Feel free to pause it along the way here if you want to get a good look at the board and see if you can see any problems. So let's zoom in. Okay, so that's the first section. Second section. Anything there? Okay, and back around. That's the Super I/O chip. And that is the back side of the board. Okay, so let's flip it and do the same for the other side. And this is the front side of the board. So let's continue our visual inspection. Like I said, if you want to pause it at particular moments just to get a better look, you're very welcome to. Okay, so anything here? Just looking for problems. Okay, can you spot anything? That's our RAM sockets. Okay, there's our ports. And back around to our BIOS battery and our processor. And back around to where we started again. These are our input MOSFETs and our DC jack. You may remember this. So what I'm going to do is I'm going to pause it here for a second. There were three things between the front and back that I spotted that might require further investigation. Why don't you pause it here and go back and see if you can find the three things. You may find three different things, but I'm going to point out the three that I think are worthy of further investigation. Okay, so the three things that stood out to me were, number one, there's a couple of marks on this IC right here. This is no smoking gun by any means. Sometimes there are just marks on these from, people haven't done previous work, or from having ripped off a piece of plastic, or just dirt on the motherboard from wherever it was stored. But I think that requires further investigation. Flipping to the other side of the board, the second thing I thought was unusual was this right here. This is just bizarre. So we've PL701, which is an inductor, and as you can see, half of the top of the inductor is broken off. Now these very rarely, I can't remember seeing one of these that failed, so I presume that it was just stored somewhere where somebody whacked off it. But you can actually see the coil. You see where it's winding around? You can actually see the inside of the coil, but that part of it is broken off there for some reason. So I just want to make sure that it's not physically damaged, and maybe it's cut from whatever whacked off it, and that maybe there's voltage here and not here. So I want to check that. But the main thing I wanted to check here is this. Now we have a sign of some sort of spill on this. So you can see on our startup chip right here, we have these three marks. We sort of start to lose definition as I zoom in. but there's definitely something has been spilled on this right here, and that is the first thing that I'm going to take a look at. So what I'm going to do is I'm going to try and clean it off and just verify the solder connections on it. Okay, so I cleaned off the 4 pins that had the green sort of spill on them, and after I did that I just resoldered each of those pins. I didn't think that there was anything wrong with them by the look of them. It didn't seem like there was any bridge between them or anything like that, but I just retouched up the solder connections anyway, just like that. From the 3 things I pointed out from the visual inspection, I've touched up the pins of the Super I/O chip as you saw in the last section and cleaned it off. The inductor that was broken off is actually working fine. It's just something must have bumped off it wherever it was stored, but it is actually fine. And the third element we were looking at was this IC right here. Again, it's probably just a mark on it, but I just need to check it. So what I decided to do was I'll just use the opportunity now and track the voltage in. We know that the 20 volt main power rail is looking like it's okay because we also had the 3.3 volt, but let's just go through it quickly. I introduced my multimeter in the volts DC range. Some of these are auto ranging, but I'm choosing the 200 volt range here because we're expecting the voltage from the LENOVO power adapter to be a little more than 20 volts, so we'll put it in the 200 volt range. I take my black probe, I will place it to ground so we can find a ground here, and then we can use our red probe to start taking measurements. So this is exactly the same as we did last week. So you can see the 2 red wires that take our positive voltage are coming in here and meet these 2 pins, and our 2 black wires come in, and this is our 2 grounds right here. And this blue wire, as we saw from last week, appears to be some sort of ID pin. But the first check we want to carry out is with our LENOVO power adapter plugged in and connected to the board, are we getting voltage on the pins here? I place my probe to this point here and we find that there is 20.32 volts. Now that we know we have power to the board, I decided we'd open up the schematic again and just go along with it. It might be useful to somebody who's maybe come across this for the first time. So what we're looking at here is we have our 20.32 volts. It then moves on to the fuse, which is PF101. So this is JDC in 1, JDC in 1. I'm following this along pins 1 and 2, which are pins 1 and 2 right here. And as you can see, PF101 is the first one in line, so PF101 is here. This is just a fuse. So we just need to know if this is blown or not. Obviously from the other work we've done on this we know it's not, but just to check it, I'll place my probe on the other side and I find that there's 20.32 on the other side of the fuse also. The next components in line after our fuse are these 2 inductors, PL102, PL101. So we've got PL101, PL102 right here. So we just need to make sure that our voltage is getting to the other side of these. So once again in volts DC, I place my red probe to the other side of the inductors and I find that there's 20.32 volts on the other side of these also. Further down the schematic I found PQ301, which corresponds to the next component in line, which is this P-channel MOSFET. So we know we have 20.32 volts here. If this is switched on, which with a P-channel MOSFET is when the gate is low, we will then find that that 20.32 volts makes it from our drain pins across to our source pins over here. Our source pins being 1, 2 and 3, which corresponds to 1, 2 and 3 here. So I measure with my multimeter right here in volts DC again, and I find there's 20.32 volts here. The gate is actually this pin here, and that is measuring 8.62, which is low, so that means the P-channel MOSFET turns on and allows our 20.32 from drain to source. So we're good up to this point. The next component in line is the second of our 2 input MOSFETs, PQ302. This is also a P-channel MOSFET. So what we need to make sure is that our 20.32, which we know is coming through the first MOSFET, that also needs to be coming through here, and then this is our main power rail. So I measure at this point here and I find that there is 20.32 volts here also. So we sort of knew this already, but I've just followed through it just to be comprehensive. Our 20.32 volts is measuring okay on our main power rail. So what do we know at this point? Well, what we know at this point is we have our main power rail, which is 20.32 volts. That corresponds to essentially this part of the circuit on the schematic. It's referred to as B+, but this is our main power rail. So all of our other secondary voltages are derived from this 20.32 volts. So what we can tell at the moment is that there is nothing wrong in this input section. You may remember the previous laptop, we had 0 volts here, and that indicated that there was actually a short in the main power rail. The fact that we have 20.32 volts here means that the system determines that there is no short on the main power rail and no major issue like that, as it's prepared to allow our 20.32 volts to come through these two MOSFETs and give us our main power rail. So the question is, what then is going wrong? So we need to troubleshoot the secondary circuits. So let's take a look at that next. Now, looking through our schematic, I spotted that we have our +3 always on power and +5 always on power. So these are the ones we need to inspect next. So where are these physically on the motherboard? If you look at the motherboard, I just scroll across here. These are normally beside each other, and I recognize these because I've worked on a few of these Lenovos. So what we have is we have PU401, which is PU401 that generates our +3 always on power, and the one down below it is PU402. So PU402 is the one that generates our +5 always on power. So what you can see here is the B+, which is what our main power rail was referred to. That comes down onto the input of PU401, and then PU401 on the output gives us +3. It's actually +3.3 volts always on power. Similarly, with our PU402, our B+, which is our main power rail, comes down through this inductor and onto the input pin of PU402, and then this generates our output, our +5 volts always on. So quite simply, just to check these and make sure that these are working, I still have my black probe on ground, still in volts DC. I measure the output of the inductor right here, which corresponds to PL402, and I find that there is 3.3 volts right here. Similarly, on the other circuit, I measure at PL404 down here, if it'll follow me. PL404, which is the output inductor on our 5 volts always on power. I place my probe here and I measure that there is +5 volts here also. So that looks good. We've established that the 3.3 volts always on is present, so what we need to do next is make sure that the 3.3 volts always on is present on our power button pins. So I've located in the schematic where our power button connector is. It's JPWRB1. I've found that on the board. I've taken this picture with the power button daughter board disconnected, but it plugs in here, and here are the pins that it connects to. So we've got 6 pins. I'm going to mark those out here. So the 6 pins, 1, 2, 3, 4, 5, 6. If we look at our schematic here, pins 1 and 2 are connected together, and they are also joined to pin 7 and 8, which are this, and they are all ground. Okay, so the next pin then is number 3, which connects to our power LED, and the next one is pin 4, which connects to our on off. So this is the important one right here. Pin 5 seems to be just connected to the 3 volts always on. I'm not sure what that function of that pin 5 is, and pin 6 is connected to our lid switch. Okay, so what I want to do here is I want to first initially check the voltage on these pins and see what we're getting. So once again, measuring in volts DC, I placed my black probe to ground, and then I checked each of the pins by just placing my red probe to each of them one by one. And when I did that, these are the voltages that I found. So on pins 1 and 2, I found 0 volts, which is correct as these are going to ground. On pin 3, I found 1.8 volts. That's the power LED. On pin 4, I found that there was 3.3 volts. So we now know that we are at least getting 3.3 volts always on voltage present at our power button. The other 2 pins, 5, I found it was 3.3 volts there also, and 3.3 volts on pin 6, which is the lid switch also. So the main thing I wanted to test here, of course, is to make sure the power button is working. We know now that it's got the 3.3 volts on the pin that goes to the power button, but we need to verify that the power button is working. So I placed my red probe to pin 4, and I observed that there was 3.3 volts on the multimeter. So I plugged in our little daughter board that houses the power button, and when I pressed down and held the power button, the multimeter which had been measuring 3.3 volts, went to 0 volts, as it should. So when I released the power button, it went back to 3.3 volts again. So it seems that our power button is working and it is sending the correct signal back to our startup chip. As one last step in troubleshooting this section, I just wanted to confirm for sure that our on-off was making it the whole way down to our Super I/O chip. So what I did was I looked up pin 4 here. I see that it's referred to as on-off. I copied that term into the search of the schematic, and I see where else that pops up on the board, and where I found it was pin 114 of the Super I/O. So what I did was I switched off the laptop, switched it to continuity mode, and did a continuity check between pin 4 and pin 114 of the Super I/O, and I found that there was a connection between the two. So the on-off is making it from the power button down to the Super I/O. Okay, so the next thing to check, you guessed it, we're going to take a look at the BIOS next. So this is our BIOS chip right here. It's a Winbond 25Q64FWSIG, and I found it in our schematic here. And as with pretty much all of the BIOS chips, this is a VCC is on pin 8. Now this one is slightly different. I didn't notice this earlier on, but there is actually a plus 1.8 volts always on with this, because this is a 1.8 volt BIOS. Many of them are 3.3 volts, but this one happens to be 1.8. So very simple check at the start in volts DC mode. Once again, we find the ground and place the probe, the red probe, to pin 8, which is 1, 2, 3, 4, 5, 6, 7 and 8, and I find that there is 1.8 volts on this pin. So the BIOS chip is getting the correct voltage also. Now just off screen, what I did was I had a spare one of these laptops that I knew was working, so I swapped the BIOS chips on the two laptops, and what I found was this one still wouldn't boot and the other one did boot with the BIOS from this board. Okay guys, unfortunately I gotta leave it there for this week. I have to go back to my real job, but this is where we are at the moment. We have a power on but no display. The laptop seems to be coming on, but there's something inhibiting it from giving us a display, whether that be the display itself or some other issue. Now I've just created a short list of possible causes here, and I want you all to go off and do this as homework and add your own ones to it if you want. Could it be a memory issue? I've tried the memory, the known good memory from the other laptop in both slots. I tried pressing down on the DIMM sockets to make sure that they're fully connected. Remember we had that issue a couple of weeks ago, so I'm not sure it's anything to do with the memory. Spill issue, I'm still not confident that there was not some other damage caused by this spill here. It seems like something was spilled on it, and maybe I'm missing something that I need to see under the microscope. That could certainly cause the same condition. BIOS issue, I've ruled that out pretty much, but I'm just listing it here because it is one of those causes that could cause this characteristic or this symptom. As I said earlier in the video, I've swapped the BIOS chip, so the one that I took out of this boots in another laptop, so I don't think that's the issue. Is it something wrong with the Super I/O chip? It seems to be responding, it's receiving the on-off signal, but is there just something wrong with it caused by this? I'll look up those pins and see what they're for. So if you just want to add other suggestions down below, I'll take a look at this later next week and I'll produce a part 2. I just have one other thing I want to say at the end here, guys. I received this comment a couple of weeks ago. Alright, so the guy G4Z-KB7CT posted, it's a nice fresh approach at scanning the board, but he just commented saying ending abruptly like that when you know the faulty part is not a good thing to do to your audience. Alright, now the same thing applies for this, but I hate cutting them short like this and not coming to a nice conclusion at the end. Last week's video was the first one that I was sort of happy with because we got to see the fault, got nice pictures of the board, got to work through it step by step, got a conclusive fix, and then I could end the video there, and you know, there was no part 2, there was no wondering what happened like we are at the end of this video. Unfortunately, because of time constraints and because, well, ability constraints as well, in that I cannot fix everything at the moment, it's just going to have to be like that for the moment. My purpose with this channel, I want to make about 20 really good videos going through each of the different scenarios and solving them from beginning to end in, very comprehensive detail. That's where I want it to be. Like I said, last week's one was where I was sort of approaching that, but I'm going to keep working on with these and see if I can get to that situation. But keep watching. I'm really interested to hear your suggestions. Did you guys see anything on the visual inspection that I missed? If you did, post it below. If you have any other suggestions as to what you might think is causing this issue, please post it below as well. And we'll pick this laptop up next week.